Okay, we're looking at 4.2. And you guys can read the introduction yourself later. Basically, we're gonna spend one day in 4.2. It's gonna be it should be an easy day today. I just want to look at one skill basically, and then also look at the graphs real quick. And then we're gonna spend 3 days in 4.3 instead of splitting up 2, we're gonna do 3 and 4.3, and then come back to assigning homework from 4.2. I think the way that 4.3 covers the material is a little better. Okay, so we're talking about logs today, or logarithmic functions, and basically all they are the inverse of the exponential functions that we've seen. So here's the definition right here. I said I was going to do it on the whiteboard, but actually I'm going to do it. I'm going to show you the graph on the graphing calculator. It'll be prettier. This is how we write it. Y is equal to log, and then the bottom number here is what we call the base. And you can kind of think of it as base because it's in the base, right? It's like on the bottom. It's in like the basement below everything. So it's in the bottom part, so it's called the base. And also because what this log means is it means that b, that base value, to the exponent is equal to the other side of the equation. All right, so you know how we talked about inverse functions before, and how to find an inverse of a function, you just reverse the x and y's and then solve, right? Well, this is what you would get if you were to take the exponential functions we talked about last time, and then you to reverse x and y's. This is the function that you end up with. Y is equal to log base b of x. All right, let me show you what that looks like on a graphing calculator. Okay, so first of all, let's just remind ourselves what an inverse function in general looks like. So remember y is equal to, let's do x squared is greater than 0. Actually, let's do one where it's clear to see. So y is equal to x cubed. I'm just gonna adjust it so it's a little more spread out. So let me change my bounds of x. I'm gonna change this to be, let's see, I want it to be smaller. There we go. It's a little more spread out, as you see. So this is y x cubed. And remember, if we have any kind of what is it, inverse function, then it will be reflected over this graph, right? So this line y is equal to x. So the inverse of y equals x cubed, remember, is y is equal to the cube root of x. Shucks, I don't know how to do this root actually. Let me see. Where's the square? Where's the cube root? Oh, here we go. The third root of x. Yeah, and see how this black graph is a reflection over that line, right? There are mirror images over this y equals x line. Yeah. Does that sound familiar to you guys? You guys remember this? I think you're all muted, so I don't hear you. So I'm not sure what you're. Let's say that you pretend that you know. Then let's I hear an objection. Okay. Anyway, let's move forward with today's stuff. Last time we talked about this exponential function. In particular, we looked at the base 2, right? Y is equal to 2 to the x. This is what the graph looks like. Right, it kind of explodes, it goes along as you go to the left towards 0, and then it goes towards infinity. So the inverse of that would be y is equal to log base 2 of x. And you see how this is a reflection over this line? Yeah, instead of going towards negative infinity in this direction, it goes to negative infinity in this direction. And everywhere along this graph, it's the reflection over this line, y is equal to x. Oh, I guess it actually doesn't look exactly like that because it's not square. So let's make our graph square. So let's say -10 to +10, and then -10, +10. So now we see more clearly that it is an exact reflection, yeah? Now that it's a square graph. Okay, sweet. So again, here's the exponential function. Here's the log function. Another thing to note is that the log function, it's not defined when you have, what is it, x equal to 0. So you see how it's approaching this line? It actually never touches that line. It gets very, very close. And as you go towards x equal to 0, it gets closer and closer to -infinity. But it never actually touches that line. It's an asymptote, really. The farther down I go, it's getting closer and closer, but it never will touch. I know if I zoom out, it looks like it's touching, but it's really just really getting close. And then as I go towards the right, it's approaching infinity. But the log function is known to be a very slow growing function. So even though it goes towards infinity eventually, this, if you zoom out, it's a very slow growth compared to exponential is like super fast, right? So let's go to the right. It's going to hit infinity eventually, but it's going to take it a long time. See how it almost looks flat if I zoom out? It is increasing, but just very slowly. Okay, so that's just kind of about the graph of the thing. And then now let's go on to the next type of question. So I'm going to stop this video.